So in today's video, we are going to wrap up our mini series on serving the data, and we'll try to go through and understand two important ideas. That is, we'll try to understand multi-tenancy and avoiding vanity analytics projects or data vanity projects. Okay, and then what we'll do is we'll try to connect all of this back to system design interviews for data engineers, and then we'll also try to connect it back to career growth. So in part one, we talked about serving the data and business intelligence dashboards, right? We talked about serving the data and the business intelligence dashboards. So in part two, we talked about operational and embedded analytics, okay? And then now we are in part three. In part three, we'll focus on how multi-tenancy works in data systems or data platforms, okay? And then why it is so important when you are serving many customers from same data platform, okay? And how actually thinking about value versus vanity or data business value versus vanity makes you sound and be more like senior data engineer or actually better engineer in general, okay? But let's try to understand what is multi-tenancy, and then let's go into more details, okay? Let's try to understand multi-tenancy. So multi-tenancy is actually about sharing the infrastructure safely, okay? Sharing the infrastructure safely. So the name itself it indicates, right? If you look at it, it consists of two words, which is multi and tenancy. Okay, so multi tenancy is so multiple customers or multiple tenants are sharing the same infrastructure. Okay, so that's what multi tenancy is all about. Okay, it's about sharing the infrastructure safely. So, and multi-tenancy is when you use the same underlying infrastructure, for example, that is like it can be databases or warehouses or data lakes or storage generally to serve, to serve for many different customers at once, okay, while keeping their data logically separated and secure, then that's called multi-tenancy, okay. So what we are saying is it's about using the or sharing the infrastructure safely, right? Okay, and what is the infrastructure that we are talking about here? Okay, so here infrastructure can be like databases or warehouses, okay, or storage in general, okay. And then for example, what is safe here? Okay, so here safe is keeping the data logically separated, okay, and of course secure. And why do you have to, you might get doubt like why do you have to keep data logically separated? That is because you have to do it because one customer, okay, should not be able to see the details of other customer, okay. Otherwise it's a data leak, and that's not good, okay, for the customers. So that's why in multi-tenancy, okay, in multi-tenancy what you'll do is, okay, you'll use the same underlying infrastructure like databases, warehouses or storage generally, okay, to serve data for different customers, okay, while keeping their data logically separated and secure, okay. So here basically what is happening is, so instead of one database per customer, okay, instead of one database per customer, here what you'll do is you'll have one big warehouse, okay, one big warehouse, or actually one big data lake actually, but one big data lake or basically or one big databases, okay, but with a tenant ID or customer ID on every row. Tenant ID or customer ID on every row, okay. So 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 in multi-tenancy what will happen is, so instead of one database per customer, you might have like one big warehouse or one big data lake or database, okay, but with tenant ID or customer ID on every row, and also basically views or policies that make the data look like per customer. Okay, so you have to keep that in mind always. So in multi-tenancy, what will happen is, there will be data, but then at the same time, you might also have like tenant ID or customer ID on maybe each and every row, or you might have some kind of tags on the data. Okay, like which data is belongs to like which tenant, or whether it is shared data and stuff like that. And then what you'll do is you'll have some kind of views or policies, and then that will make the data look like it is, it is the data of that customer only. Okay, and then data engineers normally, what they do is, data engineers normally may choose to house the data for many customers in common tables to allow for unified view. Okay, for internal analytics and machine learning purposes. Okay, and then what they do is, and then they present the data externally to customers through logical views, using filters and controls. So normally what will happen is, you'll have data here like this. Okay, you'll have data here like this, and then you'll have so many tables, right, in database. Okay, and then data engineers, what they're doing is, basically, let's say this is your storage in data engineering life cycle. Okay, so here there will be data sources. Okay, and then there will be ingestion happening into your storage. Okay, they will basically do it like this, data engineers. And then, so at the end we'll do so we'll not at the end, basically we'll do some kind of transformations, right? We'll do some kind of transformations, right? And then what will happen is, okay, we need to serve the data. And then once we are in this serve stage, what will happen is, here there will be data which is still related to many different customers. Okay, so he is different customer and he is different customer. Okay, or she is different customer and she is different customer. Okay, but then we need to show the data of this customer to only this particular one. Okay, and same for him as well, or for her. Okay, so here how we will do is, normally we in serve stage we might make some logical views or something like that using filters. Okay, when this particular user is querying the data. Okay, let's say his user ID is 1. Okay, so in filter what we should do is, basically we should show the data only related to this particular customer. And let's say this particular customer whose user ID is 2, when this particular customer is querying the data, we should only show him the data or show her the data, for whom he or she has access to see. Okay, and we should not show all other data points, okay, for which they don't have access. So that's why in serve, what we'll make is, we'll probably make some kind of logical views through filters and controls, and then show the data related to them only, So here one main important thing you need to understand is, here basically we are actually using same data platform. We are using same data platform to serve different customers. Okay, so here we are using same data platform to serve different customers. Okay, and that's what multi-tenancy is all about. It's about using the same data platform to serve, same data platform or same infrastructure to serve different customers at once, while keeping their data logically separated and secure. Okay, and how are we keeping the data logically separated and secure is by using tenant ID or customer ID, or some tags in the data and stuff like that. Okay, so that's what multi-tenancy is all about. Okay, for example, if we have to talk a little bit more about example, let's see this table. Let's say we have this particular table. Okay, so in this particular table, so what we have is, here we have raw data or events table in raw database. Okay, in this events table, basically there might be all the events from customers. okay, all the events for all customers with tenant ID. Okay, so if you have to look at the events table, okay, it might look like it might have let's say, okay, event ID, okay, event type, and then maybe it might also have not maybe it might have something like tenant ID, okay, and event timestamp and something like that. So it will have all these details, and it also has tenant ID. So 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 basically what I'm saying is, in raw table you'll have all the kinds of data, okay, for all customers, but separated on tenant basis. Okay, this you need to keep in mind. So in curate database also, you might have some fact or events table, fact events table, which will have clean and modeled version of the data. But here you'll still have data for all different tenants. Okay, it's still multi-tenant. But then now if we look at Mart, in Mart schema or Mart database, we might have a daily metrics table. Okay, and normally what you will do is, you will use this particular table or this particular table to serve data to, you know, customers. Okay, to serve data to customers. So when you use these particular tables or views to serve data to customers, so here you kind of need to have tenant level filters or tenant level controls or policies. Okay, so let's see the example. So if we look at this particular view, which is in Mart, which is created in Mart, so here we'll have tenant ID, day, total users, total revenue, and then active projects, right? So here now what will happen is, so in real system, let's say in real system, if you have a view like this, you would then combine this with, view with RLS, which is called row level security. Okay, row level security we'll use basically when we want to show the users whatever the rows related to only that particular user. Okay, and so when tenant A connects to this particular view, or when tenant A queries this particular view in Mart, okay, then what will happen is, okay, they should be able to see the rows which are only related to that particular tenant, which is tenant A. Okay, or they should be able to see the rows for which they have access to see, otherwise they should not see other rows. Okay, and same goes for other tenant as well. If tenant B is trying to connect to this particular view, okay, and see the data, they should be able to see the details related to only tenant B, and that how we will achieve is, we'll achieve that by using the row level security, which is also called as RLS. Okay, so if you have to look at it in from PySpark perspective, so in PySpark what you'll do is, you might be like extra defensive and always filter by tenant before aggregation itself. So if you look at this particular code snippet, so these are a little bit vague code snippets. This is not how you'll actually do in real world projects. Okay, you'll have more proper security measures, but these are like sample snippets to give you some kind of idea. Okay, so in PySpark how you would do is, you know, before the aggregation, before you want to calculate total active users or the total revenue, okay, what you will do is, you will directly filter by tenant ID itself. So in PySpark you might be like extra defensive and always filter by tenant before you even aggregate itself. So that is the idea. So the main idea of multi-tenancy is, you will basically use the same underlying infrastructure, okay, to serve different customers at once, while keeping their data logically separated and secure. Okay, while keeping their data logically separated and secure. So that is the main main idea behind the multi-tenancy. Okay, so and this is the kind of discipline is exactly what protects you in production also. Okay, you should always not show the data, okay, which is not related to other customers. You should only show the data which is related to, that particular customer. Okay, if I don't have access to see some kind of data, I should not be able to see it. Okay, period. and and also, if you talk, if you understand about the multi-tenancy, okay, it also shows interviewers that you understand, isolation and blast radius and security and all that kind of measures. Okay, so it actually kind of keeps you separated from those who can write simple PySpark or Python code or SQL code. Okay, so if you talk about like multi-tenancy or isolation or blast radius and security, this will kind of treat you more like make interviewers treat you more like a senior or architect kind of candidate. Okay, which is always better than getting treated as normal developers, right? Okay, so that's what you should understand. And then now actually let's move on to avoiding vanity analytics projects. Now let's talk about vanity analytics projects. Yeah. So yeah. So if you have watched my previous videos, I have always highlighted one important point, that is, okay, that is, I've been saying that data projects, all data projects, any kind of data projects, it can be data engineering project, data analyst, analytical projects, or data science project, or it can be any kind of data project. Okay, all data projects must be intentional across the whole data engineering life cycle. Okay, so what we are saying is data projects must be intentional. Must be intentional. So so data projects should have clear intention behind their existence. Okay, so everyone should basically know, and everyone should basically understand why this particular data projects exists. Okay, what is the purpose of that data project, why it is existing. Okay, which customers are you serving, what is the value that is bringing it, and what are kind of decisions that is impacting from business side, and what kind of value it is generating, whether it is like saving up revenue, or whether it is reducing some costs, or whether it is optimizing some processes. You should know the intention and purpose behind all the data projects. Okay, so now again, what does it actually mean by data projects must be intentional across whole data engineering lifecycle? What that really means is, it is very easy, especially in the cloud era, because in cloud era what might happen is, or what will happen, because I've seen it in many places, that many people end up building huge data lakes and massive data warehouses and complex streaming systems, right? And then they will at the end up with very few users or few customers. Okay, especially and then especially with the very actual real impact. So if you go to many companies, in many companies, like I have seen this multiple times. So people will have budget. Okay, if company is like literally making profits every quarter on quarter basis, then people are really like, they don't know. Some of the people are like, I don't know. People are literally blind to see, and they want to kind of over optimize and do all these data projects, and they will build like massive, huge data lakes, or huge lake houses, or massive data warehouses, and even complex ingestion or streaming systems, and then end up with very few customers. Okay, who can benefit from that data. And if you have very few customers, or if you don't have customers at all, then you don't have any kind of impact at all, from all the data project itself, right? So that's what vanity project is mainly about. So vanity project is something you might have like all the fancy technologies, and you might be using all that fancy technologies like Apache Spark and Databricks, Microsoft Fabric, Snowflake, and whatever. But you might also have all the data, but then at the end of the day, that data might not be getting used by people, okay, to make any kind of decisions across the company. So on paper, for example, a vanity project might looks like this. Okay, so let's say company might have so much raw data. Okay, company might log every tiny event from, like, let's say, every microservice into central data lake. Okay, So company might log all the raw data or all kind of events from microservices or from any kind of ODS like operational data source into central data lake. Okay, and then but it might not have clear serving layer strategy. Okay, it might not have clear serving layer strategy. Okay, even though they have all the data in the world, all the data in the company, they might not know, what is a clear, they don't have a proper strategy on serving layer. They don't know how to serve the customers or how the data can make impact to the customers. Okay, and they might not have defined stable metrics. Okay, they might not have defined stable metrics at all. Okay, and and they might actually have still a couple of dashboards. Okay, they might have a couple of dashboards. Okay, but but uh, but let's say that not many people trust the data in the dashboards. Not many people trust the data, in the dashboards. Okay, so on paper this is how vanity projects kind of look like. Even though you have all the data, okay, even though you have all the data in your data lake, but you don't have a clear server layer strategy, and if you don't have stable metrics defined, and you might have a couple of dashboards. Okay, but there might not be many people who trust that data. Okay, to make any kind of decisions, and that's what kind of vanity projects looks like. So as a data engineer, let's say as a data engineer who wants to move to higher compensation and more senior roles, okay, I think your mindset should shift from how do I bring this data and transform it to, okay, who will use this data and what they will do with it, and how does actually that shows up as revenue or savings or risk reduction or cost reduction. Okay, so what we are essentially saying is, so as a data engineer you should not just think about, okay, you should not just think about, ingestion or transformation. So it is important to think about these two, but you should not just think about only these two. Okay, you should also think about serving. You should also think about how to serve this data, which is basically who will use this data. Okay, who will use this data and what they will do with it. Okay, who will use this data, what they will do with it, and how does that shows up as value, and how does that shows up as value, which is how does that shows up as revenue or savings or risk reduction or cost reduction. So as a data engineer I'm saying you should never have mindset like, okay, how do I just ingest this data and how do I just transform this data. Okay, you should always think about the end product. You should always think about the end value, that is how do I serve this data, who will actually use it, and what they will do with it, like what kind of decisions they make by using this data, or how they can generate the value, like what kind of decisions they are making, and how it is showing up as revenue or savings or risk reduction or cost reduction. Okay, you should always think about the serving as well. Okay, so yeah, and when you start speaking like that, let's say in your system design interviews, okay, or just design reviews, people immediately hear, okay, this person actually thinks like an architect, not just like a pipeline or Spark developer or Python developer. So, and trust me guys, you should be that kind of a guy. Okay, who have like a holistic view, or who have like a clear understanding of what business wants to achieve. Not just you should not be registered as a guy who just writes code. I mean, you can also be that kind of guy that's just writing code is obviously good, because at the end of the day we are going to achieve also this by writing the code. So writing code is important, but what I'm saying is writing code is as important as understanding how that code will be useful to get value out of the data. Okay, so yeah, so now if we have to understand how this helps your career and interviews, So let's connect this directly to your careers and interviews, because that's the really point of this whole series. Okay, in many system design interviews for data engineering, questions might sound like, okay, design, let's say, okay, let's write it down maybe. No, in many system design interviews, people might ask you questions like design an analytics system for no analytics system for thousands of merchants. Okay, thousands of merchants. Design analytics system for thousands of merchants. Or you might also get question like, how would you expose, usage dashboards to SaaS customers? How would you expose dashboards to SaaS customers, software as a service customers? Okay. Or you might also get questions like, how would you handle multi-tenant reporting? How would you handle multi-tenant reporting? Okay. And maybe you might also get question like, for example, how would you keep operational dashboards accurate and fast? Okay. Operational dashboards, accurate and fast. You might get questions like this, but if you can talk through in like calm way or clear way that the difference between business intelligence, business intelligence and operational analytics and embedded analytics. Okay, if you understand the differences between BI and operational analytics and embedded analytics, and then talk through them, and how would you structure your tables and views? Okay, how would you structure your tables and views, and then how do you enforce a tenant isolation? Okay, tenant isolation, or row level security, for example. Okay, and how request patterns and concurrency would drive pre-aggregation and caching. And if you also talk through about like how all of this connects back to most important thing, which is business value. Okay, so whenever you get questions like design analytics platform for thousands of merchants, or how would you expose usage dashboards to SaaS customers, or how would you handle multi-tenant reporting on a shared warehouse or shared infrastructure, and how would you keep operational dashboards accurate and fast? Okay, so in that cases, if you talk through the nuances and differences between business intelligence, operational analytics, and embedded analytics, and if you talk through how will you structure your tables and views, and how will you isolate data, and how will you enforce row level security, and how request patterns and concurrency would drive pre-aggregation and caching, and how all of that connects back to most important, that is business value, then basically you instantly stand out, you instantly stand out from the people who talk about only tools or code. Okay, and inside your current job, this understanding also helps you challenge data vanity projects and identify vanity projects in general, and propose better serving patterns actually, because at the end of the day, most of the vanity projects are right there, because they don't have clear serving strategy. Okay, so if you can fix it, that's nice. Okay, and if you can show that you understand not just data, or if you don't understand not just a code, you also understand users, and you also understand how how to generate value from data to your business users, and that's actually where leadership and higher pay actually comes from. Okay, if you understand all these nuances, if you understand all these differences, except from just writing code and developing pipelines or designing pipelines, then only that's where leadership roles and higher pay actually comes in. Okay, and so to wrap up this whole serving data mini series, let's kind of revise a few points and then close it off. So let me repeat few important points again. Serving data, okay? Serving data is where all the data engineering lifecycle stages finally connect people to products. Okay? This is where we connect people to data products. okay, especially the products which are useful to people. Okay, so serving data is where all, where all earlier data engineering life cycle stages like data generation or ingestion, storage and transformation, where all that stages finally, connect people to products. And and this is also a place where analytics comes in different flavors like BI, operational analytics and embedded analytics. And also one more important point, that is multi-tenancy and security are central if you are serving analytics to many customers on shared infrastructure, that is you are using your shared data platform. And the most important point of all, your job as a data engineer is not only to move and transform data, but to make sure that it is useful. Okay, it is useful, it is trustworthy, it is secure and fast actually in places that matter. Okay, so you should always keep that in mind. And if this series helped you, okay, to build a clear mental model of serving the data of the serving layer, okay, and if you want more content that treats data engineering like system design, not just about scripts and tools, then please like this video and share and subscribe to this channel. Okay, and check out other videos or my previous videos on data ingestion and data transformation and data storage. Okay, and actually I would really love, and I would honestly love to hear from you in the comment section. Okay, if you are working, more on BI or operational dashboards or embedded analytics right now, or I probably think you might be working on just business intelligence or maybe operational analytics. But comment down. I would really love to hear. Like I would really love to know how many of my subscribers are actually also working in embedded analytics. Okay, and comment down actually your views on all of this series. Okay, and um, yeah, and actually also comment down if you have ever came across data vanity projects where there is no like clear serving strategy for data. Okay, yeah, and your answers will of course help me decide where to deep dive next. And yeah, and also maybe actually multi-tenancy security patterns or performance tuning for dashboards or for designing like end-to-end analytics products itself. Okay, so and thank you so much for watching. And then no, I'll probably come back to you with one more interesting topic, but until then stay tuned. And thank you so much. And yeah, good night or good morning from wherever you are watching from. And thanks again. See you. Bye.